Welcome to Math, Week 3, Linear Inequalities and Interval Notation. This is Module Math-1 on the Math Tutor Self-Study track, and today's 120-minute lesson closes with a 10-question practice quiz. Last week, you mastered the deterministic procedure for solving linear equations. This week, the equality sign becomes a strict or weak inequality, and the procedure stays almost the same, except for one rule that catches every student the first time. Phase A, Math Track, Lesson 3. This video is sponsored by Subthesis. Visit subthesis.com to learn more. Here is what we will cover in today's lesson. 6 sections in total. First, the solving procedure. You will learn how to solve linear inequalities step by step, just like equations, with full worked examples including multi-step problems that require distribution. We will also cover the 3 most common mistakes students make so you can avoid them. Second, the flip rule, when and why the inequality sign reverses, plus how to graph your solutions on the number line using open and closed dots. Third, notation. Interval notation with brackets and parentheses, plus set builder notation so you recognize both formats. Fourth, compound inequalities. The difference between and, which gives you one bounded interval, and or, which gives you 2 disjoint rays. Fifth, connection to machine learning. How linear inequalities define feasible regions in optimization problems. Sixth, practice problems and a 10-question quiz to test everything you have learned. We will start with some practice problems to warm up before the full quiz. Solve a linear inequality the same way you solve an equation. Step 1. Distribute and combine like terms. Step 2. Move variable terms to one side and constants to the other. Step 3. Divide by the variable's coefficient. The twist, and this is the only thing genuinely new this week, is the flip rule. If you multiply or divide both sides by a negative number, you must flip the inequality direction. So, negative 2x is greater than 6 becomes x less than negative 3, not x greater than negative 3. Same number, opposite direction. Adding or subtracting never triggers the flip. Multiplying or dividing by a positive never triggers the flip. Only multiplying or dividing by a negative. Let us walk through a complete example step by step. The problem is, solve negative 4x plus 7 is less than or equal to 15. Step 1. Subtract 7 from both sides. Negative 4x plus 7 minus 7 is less than or equal to 15 minus 7. That simplifies to negative 4x is less than or equal to 8. Step 2. Divide both sides by negative 4. Here is where the flip rule kicks in. Step 3. Because we divided by a negative number, we reverse the inequality direction. Less than or equal to becomes greater than or equal to. The answer is x is greater than or equal to negative 2. Always check by plugging a value back in. Pick x equals 0, which should satisfy x greater than or equal to negative 2. Negative 4 times 0 plus 7 equals 7, and 7 is indeed less than or equal to 15. The solution checks out. Now let us talk about graphing inequalities on a number line. This is the visual representation of a solution set, and it comes down to 2 decisions. First, what kind of dot goes on the boundary? Second, which direction do you shade? Here is the first example. X is less than 4. Because this is a strict inequality, less than, not less than or equal to, the boundary point 4 is not included. We mark it with an open circle. Then we shade everything to the left of 4, because x must be less than 4. Now the second example. X is greater than or equal to negative 2. This time, the inequality includes the boundary because of the equal to part. We mark negative 2 with a closed, filled-in dot. Then we shade to the right because x must be greater than or equal to negative 2. Here is the quick rule to remember. Strict inequality, meaning less than or greater than, gets an open dot. Inclusive inequality, meaning less than or equal to, or greater than or equal to, gets a closed dot. Then shade in the direction of the values that make the inequality true. The flip rule is not arbitrary. Multiplying by a negative reflects the number line through 0. Picture it. 5 sits to the right of 2, so 5 is greater than 2. Now multiply both numbers by negative 1. Negative 5 lands to the left of negative 2, so negative 5 less than negative 2. The relative ordering reversed because reflection swaps left and right. The flip rule simply preserves the truth of the statement under that reflection. If you do not flip, you have lied. If you do, you have told the same truth in mirror image. This is also why, in optimization, negating an objective function flips a maximization problem into a minimization problem, the same monotonic decreasing transformation logic. Before we move on, let us look at the 3 most common mistakes students make with inequalities. Knowing these traps in advance will save you points on every test. Mistake number 1. Forgetting to flip the inequality when dividing by a negative. For example, negative 3x is greater than 12. If you divide both sides by negative 3 and write x is greater than negative 4, that is wrong. Because you divided by a negative, the sign must flip. The correct answer is x is less than negative 4. This is the single most common error in this entire topic. Mistake number 2. Putting a bracket on infinity. If x is greater than or equal to 2, the interval notation is 2 with a bracket, comma, infinity with a round parenthesis. Writing a bracket on infinity is always wrong because infinity is a direction, not a number you can reach or include. Mistake number 3. Confusing open and closed dots on the number line. If x is strictly greater than 3, that means 3 itself is not included, so you use an open dot, not a closed one. Closed dots are for less than or equal to, or greater than or equal to. Here is a quick self-check you can use. After solving any inequality, plug your answer back into the original. If it does not work, check whether you forgot the flip or mixed up your dot type. Interval notation is shorthand for what set does x live in. A round paren means the endpoint is excluded. A square bracket means the endpoint is included. So AB is strict on both sides. A is less than x less than b. AB is inclusive on both sides. Mixed forms like AB are common, closed on the left, open on the right, meaning A less than or equal to x is less than b. Infinity always uses a paren. Infinity is a direction, not a number, so you cannot include it. A statement like x less than or equal to 5 becomes the interval from negative infinity to 5, inclusive, round on the infinity side, square on the included endpoint. Some textbooks and courses use set builder notation alongside interval notation. Both describe exactly the same solution set, just in different formats. It is worth knowing both so you are not caught off guard on a test. Set builder notation looks like this. Open brace, x, vertical bar, then a condition, close brace. The vertical bar is read as such that. So the set, open brace, x, vertical bar, x is greater than 3, close brace, reads as the set of all x such that x is greater than 3. In interval notation, that same set is the interval from 3 to infinity, open on both sides. Here are 4 side-by-side comparisons. X is greater than 3. In interval notation, open parentheses, 3, infinity, close parentheses. In set builder, open brace x such that x is greater than 3, close brace. X is less than or equal to 5 becomes open parentheses, negative infinity, 5, close bracket. And in set builder, open brace x such that x is less than or equal to 5, close brace. For compound inequalities like 1 is less than x is less than or equal to 4, interval notation is open parentheses 1, 4, close bracket. Set builder is open brace x such that 1 is less than x is less than or equal to 4, close brace. The union case, x is less than negative 2 or x is greater than 6, uses the union symbol in interval notation. In set builder, you simply write the word or inside the braces. You do not need to memorize both formats for this course. Just recognize set builder when you see it and know that the vertical bar means such that. Compound inequalities come in 2 flavors, and, also called intersection, requires both conditions simultaneously. Negative 2 is less than x less than 5 means x is greater than negative 2 and less than 5, one bounded interval. Geometrically, you are intersecting 2 rays and keeping the overlap. Or, also called union, requires only one condition. X less than negative 2 or x is greater than 5 means x lives in either ray. The solution is 2 disjoint, unbounded intervals, written with the union symbol. The open interval from negative infinity to negative 2, the open interval from 5 to infinity. Do not try to compress an or into a single chained inequality. There is no chained form for disjoint rays. When you do have a 3-section and, like negative 2 is less than 2x, 3 less than or equal to 5, perform every operation on all 3 parts simultaneously. Add 3 across all 3. Divide by 2 across all 3. 3 reasons to care about inequalities beyond the quiz. 1. A single linear inequality cuts the number line, or the plane, in 2 variables, or higher dimensional space, into a half region. Intersecting many of them produces a bounded convex feasible region, a polytope. 2. Machine learning objects with the same structure. Constrained optimization is everywhere, non-negative matrix factorization, support vector machine margin constraints, linear programming relaxations of integer problems. Each is a system of linear inequalities defining a polytope, with an objective optimized over that polytope. 3. The computational payoff. Solvers exploit convexity to find the optimum in polynomial time. Recognizing your constraints as a linear inequality system is what lets you reach for a linear programming solver instead of writing a slow custom search. The same flip rule, the same intersection versus union language used at scale. Time to check understanding. 10 questions ahead, pause after each prompt and try it before I reveal. The quiz targets the trap families this lesson named: the missed flip trap, the inclusive versus exclusive endpoint trap, and the and versus or confusion. Hit all 10 and you are ready for absolute value inequalities. Let us tackle a problem that requires more setup before you can isolate x. The problem is, solve 3 times the quantity x minus 2 plus 4 is greater than 2x plus 1. Step 1. Distribute the 3 into the parentheses. 3 times x is 3x. 3 times negative 2 is negative 6. So the left side becomes 3x minus 6 plus 4 is greater than 2x plus 1. Step 2. Combine like terms on the left. Negative 6 plus 4 is negative 2. So we have 3x minus 2 is greater than 2x plus 1. Step 3. Subtract 2x from both sides to collect the x terms. 3x minus 2x is x, so x minus 2 is greater than 1. Step 4. Add 2 to both sides. X is greater than 3. The solution is x is greater than 3. In interval notation, that is the interval from 3 to infinity, open on both sides. Notice that no flip was needed here. We never multiplied or divided by a negative number. The distribution and combining steps came first. The flip rule only triggers when you divide or multiply both sides by a negative. Before we jump into the quiz, here are 3 quick practice problems. Pause the video and try each one on your own before I reveal the answer. Problem 1. Solve 5 minus 2x is less than 11. Take a moment. The answer is x is greater than negative 3. Here's how. Subtract 5 from both sides to get negative 2x is less than 6. Then divide by negative 2, and because you divided by a negative, flip less than to greater than. X is greater than negative 3. Problem 2. Write x is less than or equal to 7 in interval notation. The answer is, open parenthesis, negative infinity, comma, 7, close bracket. Negative infinity always gets a round parenthesis. 7 gets a bracket because it is included by the less than or equal to. Problem 3. Graph x is greater than or equal to negative 1 on a number line. The answer is a closed dot at negative 1, shade to the right. Greater than or equal to means the endpoint is included, so closed dot. Shade right because x must be bigger. If you got all 3 correct, you are well prepared for the quiz. If any tripped you up, consider reviewing the worked examples and the common mistakes slide before continuing. Question 1. Solve 2x plus 1 is less than 9. Pause. The answer is x is less than 4. Subtract 1 from both sides. 2x is less than 8. Divide by 2, positive divisor, no flip, to get x is less than 4. Choice B, x is greater than 4, is the false flip trap. Students flip when they should not. The flip rule applies only when you multiply or divide by a negative. Choice C silently strengthens the inequality from strict to weak, which loses information. Question 2. Solve negative 3x greater than or equal to 12. Pause. The answer is x less than or equal to negative 4. Divide both sides by negative 3, which flips greater than or equal to less than or equal to, giving x less than or equal to negative 4. Choice A, x greater than or equal to negative 4 is the missed flip trap, the dominant failure mode in this entire lesson. The student divided by negative 3, but forgot to reverse the inequality direction. Choices C and D drop the negative sign on negative 4 entirely. Question 3. Write x greater than or equal to 2 in interval notation. Pause. The answer is the interval from 2 inclusive to infinity. Close bracket on 2 because greater than or equal to includes the endpoint. Round paren on infinity because infinity is a direction, never a number you can include. Choice D, to infinity, is the bracket on infinity trap. Square brackets on infinity are always wrong. Choice A drops the inclusion of 2. Choice C reverses the direction. Question 4. Solve the compound inequality 5 is less than 2x plus 3 less than or equal to 11. Pause. The answer is 1 is less than x less than or equal to 4. Subtract 3 from all three sections to get 2 is less than 2x less than or equal to 8. Divide all three sections by 2 to get 1 is less than x less than or equal to 4. Choice C, 1 less than or equal to x is less than 4, is the endpoint flip trap. The inequality types on the original sections are strict on the left and weak on the right, so the answer must preserve the same pattern. Choices B and D mishandle one or both endpoints. Question 5, free response. Solve for 2x is greater than 10. Pause. The answer is x less than negative 3. Subtract 4 from both sides. Negative 2x is greater than 6. Divide by negative 2 and flip the inequality, x less than negative 3. This question targets the missed flip trap dead on. If you wrote x greater than negative 3, the symptom is identical to forgetting the flip. Your algebra was right except for the direction. Question 6, free response. Write x is between negative 2 and 5 inclusive in interval notation. Pause. The answer is the closed interval from negative 2 to 5. The word inclusive tells you both endpoints are included, so square brackets on both sides. The lower endpoint is negative 2. The upper is 5. This drills the inclusive versus exclusive endpoint trap. Students who default to round parens for everything end up with the open interval from negative 2 to 5, which silently excludes the boundary. Question 7, free response. Solve and write in interval notation. Negative 3 less than or equal to 2x. 1 is less than 7. Pause. The answer is the interval from negative 1 inclusive to 4 exclusive. Add 1 to all three sections. Negative 2 less than or equal to 2x is less than 8. Divide all three by 2. Negative 1 less than or equal to x is less than 4. The original section types, weak on the left, strict on the right, propagate to the interval. Square bracket on negative 1, round paren on 4. Half-open intervals like this are the mixed endpoint trap. Sloppy notation collapses them into something like the open interval from negative 1 to 4 or the closed interval from negative 1 to 4, both of which lose information. Question 8. The compound x is less than 1 or x is greater than 4 in interval notation. Pause. The answer is the open interval from negative infinity to 1 union the open interval from 4 to infinity. Or means union, two disjoint open rays. Strict inequalities give open parens on the finite endpoints. Infinity always gets a paren. Choice A, the open interval from 1 to 4, is the and versus or confusion trap. That is, the complement of the correct answer, the bounded interval between the rays. Choice C silently includes the endpoints, which the strict inequality forbids. Question 9. A feasible region in linear programming is bounded by what? Pause. The answer is linear inequalities. Each constraint in a linear program is a single linear inequality, and each one cuts the plane, or higher dimensional space, into a half region. The intersection of all those half regions is the feasible region, a convex polytope. The objective is then optimized over that polytope. This is exactly the structure you just drilled on the number line, scaled up to 2 or more variables. Question 10, the reveal question. Why does flipping the inequality when multiplying by a negative matter geometrically? Pause. Multiplying by a negative reflects the number line across 0. A statement like x is to the left of 4, that is, x is less than 4, when reflected becomes x is to the right of negative 4, which is x greater than negative 4. The flip preserves the truth of the statement under that reflection. It is not an arbitrary rule. It is bookkeeping for what the geometry already did when you negated. This same logic is why negating an objective function turns a maximization into a minimization, the same monotonic decreasing transformation. Let us recap everything from today's lesson. The procedure. Solve an inequality the same way you solve an equation. Isolate the variable by adding, subtracting, multiplying, or dividing. We walked through full worked examples, including multi-step problems with distribution. The flip rule. Whenever you multiply or divide both sides by a negative number, reverse the inequality direction. We also covered how to graph solutions on a number line using open dots for strict inequalities and closed dots for inclusive ones. Watch out for the 3 most common mistakes: forgetting the flip, putting a bracket on infinity, and confusing open and closed dots. Interval notation and set builder notation. Brackets mean the endpoint is included. Parentheses mean it is excluded. Infinity always gets a parentheses. Set builder notation uses braces with a vertical bar read as such that. Compound inequalities. And means intersection, 1 bounded interval. Or means union, 2 disjoint rays. Connection to machine learning. Linear inequalities define half spaces and feasible regions used in linear programming, support vector machines, and constraint satisfaction. That wraps week 3. Next week we take on absolute value equations and inequalities. Next week wraps absolute value mechanics around equations and inequalities. You will learn the structural difference between absolute value of x less than or equal to k, 1 bounded interval, and or intersection, and absolute value of x greater than or equal to k, 2 unbounded rays, an or union. The same pattern reappears when you study L1 regularization and confidence intervals. Lesson 4 also includes a cumulative review covering weeks 1 to 3. That wraps up week 3. Thanks for studying. If this lesson helped, please like and subscribe. It tells the algorithm to put this in front of more learners. See you next week for absolute value inequalities. Sponsored by Subthesis, subthesis.com.